Hi, this is Preeti Shinde and I'll be explaining the role object pattern. The intent of this pattern is to adapt an object to different client needs through attached role objects. These objects represent a role the core object has to play in that specific client context. The core object can manage its role dynamically. By representing role as individual objects, the different contexts are kept separate and system configuration is simplified. Motivation. Let's take an example where a person works on a film. In a film, different person can have different kind of roles like director, actor, music player, scriptwriter, etc. So a particular person can be attached to two roles. For example, an actor can also be a director. Modeling for such a concept would require that a class could play more than a single role. The solution of inheritance in this case is not possible, as this would allow a person to play only a single role. Using inheritance, we can say that an actor who is a person is playing in a film, but there is no way to say same person playing the role of actor is also a director, because inheritance makes a character person in general, not a particular person. If your application wants to list the people involved in the film, we will have two objects, actor and director of the same person, unless we handle the duplicates. The expectation is to have a pattern where a single object be seen more than one role and where attributes behavior specific to one of these roles. Applicability. Role object pattern can be used in following situations if you want to handle a key abstraction in different contexts and you do not want to put the resulting context specific interfaces into the same class interface. It can also be used when you want to handle available roles dynamically so they can be attached and removed on demand, that is at the runtime, rather than fixing them statically at the compile time. When you want to keep client role pairs independent from each other so that changes to a role do not affect the clients that are not interested in that role. Structure of the role object pattern. So we have the component abstract class. Component role inherits from this abstract class, and component role is also an abstract class. Concrete role A and concrete role B are the concrete class of component role. Component core is the main core object which will be referenced in component role as a decorator, and component core inherits from component. So the component will have all role specific behavior like add role, which adds to the role, adds the role to the object. Has role identifies if the particular role exists. Remove role removes the role, and get role gets the actual role object. Let's take a look at participants again. In my demonstration, I have used example of employee role. Employee can play different kinds of roles like developer, tester, business analyst, etc. Component component models a particular key abstraction by defining its interface, specifies a protocol for adding, removing, testing, and querying for role objects. A client supplies a specification for concrete role subclass. In the simplest case, it is identified by a string. Component core implements the component interface, including the role management protocol, that is, creates the concrete role instances, manages its role objects. Component role stores reference to the component core and implements the component interface by forwarding requests to its core attribute. Concrete role models and implements context specific extension of component interface and can be instantiated with component core as an argument. Collaborations. Component role forward its request to component core object. Component core instantiates and manages concrete roles. A client can extend the core objects with roles. To this end, he describes the desired roles with the specification objects. Whenever the clients want to work on a core object in a role specific way, he asks the core object for this role. If the core object is currently playing the requested role, it is returned to the client or else it throws an error. Consequences: roles can be evolved easily and independently of each other. Like component interface is very easy because you will not have to change the component core class. A concrete role class lets you to add new roles and role implementation while preserving the key abstraction. For example, if we have two concrete role classes like tester and developer, and if we want to add another role, a BA role, then we don't have to change the extending component interface, that is extending employee class, and we just have to add a BA role. I'll be showing it during my demonstration. The role object can be added and removed at runtime simply by attaching it to an object or detaching it from the core object. Thus, those objects that are needed in a given situation are actually created. For example, for a particular period of time, you want the object to play a certain role, and later on, if you don't want it, you can just call a remove. Once you attach the role, you do role specific behavior, you can always remove the role. Applications get better decoupled by explicitly separating the component interface from its role. The coupling of the application is based on different role extensions is discrete. Let's say client A uses component interface and some context specific client role classes does not need to know client role classes which other applications like client B uses. For example, if the client A uses concrete role A and client B uses concrete role B, then client A do not have to know about concrete role B. Same goes with client B. Client B do not have to know about concrete role A. So the application gets better decoupled. The pattern avoids the combinatorial explosion of classes as it would result using from multiple inheritance to compose the different roles in a single class. Disadvantages and liabilities. Clients are likely to get more complex because working with an object through one of its concrete role interfaces implies slight coding overhead compared to using the interface provided by component interface itself. A client has to check whether the object plays the role in the question. If it does, the client has to query the role. If it does not, the client is responsible for extending the core object in its specific use context, provided that the core object actually can play the role. Constraints on role cannot be enforced by type system. You might want to exclude certain role from being attached to the same core object in combination, or certain roles may depend on existing of others, that is role dependencies. With the role object pattern, you can't rely on type system to enforce the constraints for you. You will have to use runtime checks instead. Maintaining the constraints between role becomes difficult since subject consists of several objects which are mutually dependent. Maintaining constraints and preserving the overall subject consistency might become difficult. Let's have a look at the implementation section. So, as I said previously, I have taken employee as a core role object and developer and tester as concrete role objects. So, so I have get name and get ID, which will represent a single class employee, and developer and tester will have specific behavior, that is do coding, testing, component core will be referenced in employee role object. So this is the abstract class which has get name, get ID, and all role specific behaviors like get role, add role, remove role. Com- employee core extends employee. So this is the constructor. We pass name and ID, and employee core is constructor. This is the implementation of the component in get role. We have created a role hash map over here. We add the role name and the role object while adding into the roles, and removing we have to specify the string, and the role object is removed from the list. Has role checks whether the specific role exists in the array list. Employee role extends employee. It has a reference to employee core, and it gets all the details from the employee core object. These are concrete classes. Developer, which extends employee role. This is specific coding behavior. And employee core, we pass it into the constructor. Same goes with tester. Do testing is testing specific behavior added to tester role. Let's take a look at the demo. So what I have done is I have created a list of employee. I've passed the name and the ID to create employee core object. So I've created three core objects. To core up to James, I have added the role of developer. So what we have to do is we have to create a role object and pass this core object. Employees.getZero will give this core object James. Pass it to the constructor. Then we add the specific role to it. Same way goes for Ben. Create tester role object and add tester role to it. For Tom, we'll actually try to see like how a single Tom can work as both tester and developer. So we create a tester role object and add it to Tom. Create developer role object and add it to Tom. So employee list will construct this employee and add related roles. Then we loop over the employee list, and for every employee object we check whether the object has the role developer. If it has the role, it gets the object and downcards is to the developer. Similarly with tester. So if I run this program, what I expect is James will say I'm coding. Ben, as is the tester, he'll say I'm testing. Tom, he's a developer as well as tester. So he'll say I'm developing, I'm testing. So I'll run this application. So these are the results. I'm coding, I'm testing. Tom, I'm coding, I'm testing. So we see how single object can play a role of developer as well as tester. So in case if I have to add another object, what I have to do is add a role, extend employee role, add the constructor with core object as its parameter. Add the BA specific behavior so we have BA role already set. What we do is we add the same person BA role as well. So what we do is we create BA role object, add that role to Tom, and if the client wants to access that role as well, add another if block, get role VA. So now we expect Tom to say, I'm coding, I'm testing, and I'm analyzing. So Tom is now able to perform all the three roles. That's it. Thank you.